Hello and welcome to the video tutorial Setting a Grid. In this video we will explore the methods and techniques to quickly and accurately set up a typical grid from point cloud data. Taking some time to properly set up a grid can be one of the most important steps in our drafting process because it will allow you to get clean, nominal offsets. We will accomplish this step by using some basic AutoCAD functions, but the most important skill is recognizing the patterns of a building. Here we begin with a file already set up for us that has the point cloud inserted and the crop states already done and saved. Looking at the overall perimeter, it is easy to see that the columns make a nice visual pattern. We will start by making the overall extents of the perimeter. Try to get everything with nice round numbers. Not all buildings will have nice even numbers, but we will always strive for this scenario. When trying to find the best fit grid lines and dimensions, there are several ways to accomplish this. Use whatever method works best for you, but you will see I go through quite a few different options before settling on the dimensions I like best. It is important to take your time with getting a good grid, as it sets the tone for the entire project. You can try to find the midpoint of the columns to start with to find the best grid dimensions, but this won't always work, as you might find yourself moving lines a lot. The same grid offset didn't work for me on this part, even after playing with the center positions a little bit. An easier way to find the best grid for this building was to use the point cloud data and find a typical column size. For this building, it ended up being 1'10". From there, you can use the middle of 2 points snap to draw your grid lines in the center of the typical columns. You can see here when I went to the opposite side of the building to check the columns and grid lines, things don't quite match up. There can be many reasons why this happens. The point cloud could be rotated slightly, causing the lines to be angled, or the building could have multiple grid lines. Since we are only concerned with finding the best fit for a grid, you will have to use your best judgment and play around with the grid lines to find something that works around the building as a whole. Don't forget to check the interior columns to see if your grid lines match up with those as well. You'll want to check the dims and make note of any grid lines that don't match the typical offset. I like to draw rectangles around the grid lines I feel may need to be moved to fit the best scenario. I'll go back over the dimensions and make sure they all match, and the outside grid lines have typical dimensions to the outside perimeter. This step in drafting a building can seem tedious, but it is really important to make sure our grid is correct. If you ever want to see an example of bad CAD, just look at most of the client CAD we receive from other firms and businesses. It is riddled with fractions and crooked lines. This is why we strive to get our buildings to be nominalized with clean offsets. You can see here that I put rectangles around some problem areas. These don't quite line up with the point cloud data. However, since the problem areas do not have a pattern to them, I've made a decision to keep my typical grid dimensions. If the three along the bottom were in the same order and orientation as the top, I might have to go back and make changes to my grid. If you come across something like this and are not sure what to do, you can always put an RFI cloud around the area for the review team to look at and give you advice. Once you are satisfied with the grid dimensions, it's time to finalize the grid. There are a couple ways to do this. I'll show you the long way first, and then my preferred method. Changing the grid lines themselves is as easy as changing the layer to G Grid. The grid labels are not necessary, but make the drawing look more professional and complete. We will use a 2-foot diameter circle and place the label inside of the center. Use the Mooly text with a 2-foot text height and make sure to change the text justification to middle center. Copy these grid labels around and change the text inside to reflect a logical grid label order. Place the grid labels on the correct layer, which is G grid label. The faster method for changing your line work to a grid is to use the Enhanced Custom Grid command, which will change your line work and complete the grid for you. The only downside to this is this feature is only available in the architecture version of AutoCAD. If you're using a different version of CAD, this menu and tool may not be available. This command will change the layer type to a grid layer and insert grid labels at each endpoint of the grid, making it go by much faster than having to do it manually. After running the command, you simply change the layer to our grid layers, edit the labels, and you're done. In most cases, we do not need to show the duplicate grid labels. You can copy them around, but you see here that I simply remove the bottom and right side. It doesn't matter which sides you keep, as long as you have one set for each of the vertical and horizontal grid lines. This concludes our video tutorial of setting a grid. I hope you learned something, and thanks for watching.